So if this is the source charge at point P, if you want to calculate which is at a distance r, what will be the electrostatic potential at point P? It is K₂ by r. It is positive for, potential is positive for positive charges and negative for negative charges, right? So if it is a negative Q, then potential at the point P will be what? Vp will be equal to minus K₂ by r. It is a scalar quantity, only with the sign we need to consider. So from this equation, what you can say, that potential at a point is directly proportional to the magnitude of the source charge. And what else it depends on? It is inversely proportional to the distance of the wording. If you want to write, V is inversely proportional to the distance of the point from the source charge. These two things you have to keep it in mind. It is directly proportional to the magnitude and inversely proportional to the distance from the source charge. And it is positive for positive charge, negative for negative charge at any point. See, this one we call it as absolute potential. Absolute potential depends on what? Depends on the reference point you are taking. Right? If you take infinity as your reference point, at infinity we consider that electric potential is 0. So absolute potential depends on the reference point. This point you are able to follow. This one we call it as what? Absolute. Whenever you talk about work done in bringing a unit positive charge from infinity to that point, then that is known as absolute potential. Okay? And absolute potential depends on reference, because we consider here what? At infinity it is 0. If I change from infinity to somewhere and I keep it as 0, then it will vary. And this potential, but potential difference does not depend on the reference point. Potential difference, okay, is significant. The reason is it is not depending on the reference point. It is, if you consider that A and B. Definitely you know that the distance of A is lesser than B. So VA will be greater than VB. This is absolute potential you are talking about when I consider the infinity as my reference point. But what is the potential difference between VB minus VA? This does not depend on the reference point, right? Wherever you take, keep the C point as reference, and from here you are calculating the VA, VB, it will change. But when you calculate the difference between VA and VB, it will not change. It is a fixed point. It is fixed for any reference point. Clear, ma'am?
Yes, ma'am.
Now, next one is graph of potential versus distance. Just now we have seen that it is inversely proportional to the distance, right? V is inversely proportional to the distance from the source charge. It is K₂ by r. Here Q is constant for a given charge. K is inversely proportional to the distance. So we can have two graphs. See, one is for positive charge, that is Q greater than 0. So what is the graph? When you draw the graph between potential and distance, you will get, you have the inverse relation. So rectangular hyperbola you get. Clear, ma? Here we have the Cartesian system. You need not draw on one side. You can draw on both the sides. Because from the positive charge, if you take this point, here also the potential will be there. Here also the potential will be there. It will be same, right? On both the sides, spherically symmetric. So you can draw on both the sides of the graph. Exam if they ask single this first quadrant is more than enough. V versus R, only rectangular hyperbola. Okay, this is V versus R. If they ask you P versus 1 by R. Then it has a direct relation for Q greater than 0. You will get a graph. Here V is directly proportional to 1 by R. Okay, this is for positive charge you are learning. Here, for negative charge, how will you draw that? Since V is negative for negative charge, correct? So V due to the point. Here if you take minus Q, then what it will be? Vp will be equal to minus KQ by R. So V is negative for negative charge. So which quadrant it will come? The negative y-axis, right? The fourth quadrant you have to draw. This is minus V, this is R. So how it will be? It will be like this. Here. And V inverse relation, if it is V versus 1 by R, how it will be? This is the graph. Clear or no? All these graphs? Tell me if it is not. Clear, ma?
Yes, ma'am.
Yes, ma'am.
Next, graph of electric field intensity, potential, and the distance of the point from source charge. Concentrate. This graph is important. See, we know that E equal to electric field intensity at any point due to a source charge is given by KQ by R square. Positive charge, take the same example. So this is the point P. What is the electric field at this point P? It is nothing but KQ by R square. And what is the electric potential at the point P? It is KQ by R. So I am going to write this. From this, what we can write? Draw the graph between these two things. See, E is inversely proportional to the square of the distance, whereas V is inversely proportional to the distance. So when you draw the graph between these two things by taking R along x-axis, E and V along y-axis, two graphs, two lines you need to draw. So I will draw the V graph with red line and E graph with blue line. Here, see, you can see one point, they intersect with each other. But we will just, at this point, you can see that E value is equal to V, and what is the value of R? For this, you can use the simple thing where R is this, and E is inversely proportional to the square of our distance. V is inversely proportional to the distance. Now tell me, when R is infinity, what will happen to the E value, ma? 0, 0. When R equal to 0, what will happen? This will become infinity and infinity. Now, when R equal to 1, what will happen to E and V? It will be equal to 1, right? Or equal to, E will be equal to V. When R is equal to 1, that time when you divide it by square of 1, it will remain same, and when you divide it by R, you will get the same answer. So E will be equal to V. Here on, when R is greater than 1 and lesser than 1, here only you need to find it. When R is greater than 1, what it will be, ma'am? When R is greater than 1, you are dividing it by R square. So definitely, what will happen? V will be greater than E. Hope you are able to follow. You are dividing the numerator by what? R square, whereas here only R. So what happens? Here R is greater than 1. Here V will be greater than E. When R is less than 1, that time what will happen? E will be greater than V. If it is not clear, let me know. Clear? Teacher and we know?
Yes, ma'am. Yes, ma'am.
So that's why at this point, they both intersect with each other. That is R equal to 1. That time E will be equal to V. When R is greater than 1, that is this region. What happens? V is greater than E. That's why you see the graph. Automatically the graph, in that the line, V line is above this E. And here if you look at it, R is less than 1. What happens? E value is greater than V. So this way you can remember this graph. Is it clear, this graph?
Yes, ma'am.
Okay, now we will see some of the numericals relating to this topic, and then we will move to the next topic. Clear or no? So now we will just see the work done in moving. What are all the formulas so far we have learned? Electric potential at a point is defined by work done in bringing a unit positive charge from infinity to that point. Okay. Otherwise, work done in bringing the Q naught charge. So W by Q naught, and work potential can be given as potential energy by Q naught, or U equal to Q naught into V we have learned. And what else we have learned? Any other formula? Then VB minus VA is nothing but what? Work done in bringing the charge from potential difference. Work done in bringing the charge from A to B. It's nothing but the potential difference between these 2 points. So all these formula, keep it in mind, we will do one by one. The work done in moving a charge of 3 coulomb from a point A, which is at a potential minus 2B, to the point, another point B is 18 joule. So they have given what? Work done is given in this question. Find VB they have asked. So how to find out? Use this formula and we can easily solve it. So one by one we will do that. Any doubt in this formula, you just let me know. Clear?
Yes, ma'am.
Okay. So already I have sent this through mail, so you have the questions. So you need not copy the questions, only just take down the solution only. So which formula we can apply for this, ma? Answer. Which formula? Here work done is given. Different. So how we to calculate? Apply the same formula. Work done in moving the point A is at potential, that is VA is nothing but what? Minus 2 volt. Another point VB we don't know. The work done in moving the charge from A to B is given as what? 18 joule. We need to find out the potential difference. So how we to calculate? Apply the same formula. So what it is? VA the final potential minus initial potential, or what you can do? Work done in bringing this charge by Q is nothing but what? VB minus VA, final potential minus initial potential. Yes or no? Let me close it and open again. If it is not clear, let me know. Now, so work done, what it is given? 18 divided by 3 coulomb. No need to convert because everything is in SI unit. So VB minus 2 volt. Right? Even you need not write V. So what it will be? It is 6. 18 by 3 is 6. VB plus 2. Okay. So now what will happen? VB will be equal to 6 minus 2. That will be equal to 4 volt. Is it clear or no? Everyone? This is given, the charge is given. So how to find out the electric potential at this surface? How will you do it? Nucleus is spherical in nature. That is what we consider, right? Nucleus is spherical in shape. So if it is spherical in shape, you know that the radius is given 9 into 10 to the power minus 3 centimeter. It is given. So you have to convert into meter. That is 10 to the power minus 15 meter. What else is given? Charge on proton. Okay. So charge on proton Q is given as 1.6 into 10 to the power minus 19 coulomb. That is plus. How many charges are there? That is atomic nucleus 50. Okay. That value is given as 50. What is that value, ma? It is nothing but what? Number of protons. So they have given you the fundamental charge E. So what is the number of protons present in that? It is 50 number of protons. So total charge, if you take it, Q will be equal to N into E. So N is nothing but 50 into 1.6 into 10 to the power minus 19 coulomb. Any doubt, let me know. So what is potential? Electric potential on the surface. At the surface, what is the distance of the charge? This is the sphere, right? From the center, this is the radius. Radius is given. Okay. So V will be equal to K small q, that is Q by R, the total surface. You can write small q or big Q, that doesn't matter. I don't know why it's not working. So 9 into 10 to the power 9. What is the value of K? 9 into 10 to the power 9. What is the Q value? It is 50 into 1.6 into 10 to the power minus 19 upon the distance is 9 into 10 to the power minus 15 meter. So 9 will get cancelled here. In this, it will become 4 minus 4. So that will give you 50 into 1.6 into 10 to the power 5. Okay. So 16, it is 80, right? So 16 5s are 80, correct, right? Into 10 to the power 5. So 8 into 10 to the power 6 volt. Clear or no?
Ma'am, sir.
Good.
Yeah, ma'am.
Good. Next. Oh God. Calculate the potential at point P due to a charge located 9 centimeter away. So this is the point and the charge is located at 9 centimeter away. So our distance is given and the charge value is 4 into 10 to the power minus 7 coulomb. Okay. So we need to find out the potential. Very simple. We know the formula K Q by R. So what is the value of K? It is 9 into 10 to the power 9. What is the value of Q? It is given 4 into 10 to the power minus 7 divided by 9 centimeter is given. So you need to do the conversion. So better you list out the data as usual. It is this one. R is given as 9 centimeter. Immediately you convert and write so that you will not miss when you substitute it. Now 9 will get cancel out. 4. This will become minus 5. So 4 into 10 to the power 5 volt. Minus 2. It is minus 5. Yeah, 4, right? 9 minus 5 is 4. 4 into 10 to the power 1. Now what they have asked, hence obtain the work done in bringing the charge of Q from infinity to that point. So we are having a Q here. It is at infinity. What is the value of it? 2 into 10 to the power minus 9. From infinity to this point, we need to bring it. So what is the work done? Work done, how will you calculate? We know that V equal to work done by Q naught. So if you want work done, then Q naught into V. Can we do that? So V value, we know that. So what is the V value? Q naught also given. Q naught is given as 2 into 10 to the power minus 9. What is the potential value? 4 into 10 to the power 4. So on calculating 8 into 10 to the power minus, what is this value? Minus 5. 9 minus 4. Is it clear now, Visham?
Yes, ma'am.
Does the answer depend on the path along which the charge is brought? No, because the answer does not depend on the path along, because electric field is conservative, right? Electric force is conservative force, conservative in nature, and it is path independent. It does not depend on the path in which you take the charge. It depends only on the final and the initial position of the charge. So that's why we call it as conservative. One of the definition of conservative is what? It is path dependent, independent, path independent. Is it clear now? If this one is clear, then I will move to the next one. Just stop me if it is not clear. Okay, the next one is electric field intensity at point B. So let us consider the point B is here due to a point charge Q. Okay, at A is 24 Newton per Coulomb. So what they have given electric field at point B due to the point charge. So this is given as EA, right? Because here the charge at A is producing what? The electric field. That is given as 24 Newton per Coulomb. Is it clear, Jala? See what they have given electric field intensity at point B due to the charge Q. So that means it is producing the electric field and this electric field value is 24 Newton per Coulomb. And the electric potential at B due to the same charge BP is given as what? 12 Joule per Coulomb. Calculate the distance AB and also the magnitude of the charge at Q. Okay, so we need to calculate two things. One is small q, we will take it. Okay, let the charge at Q is B. The another one what we have to calculate? AB distance. Let A and AB equal to R we will take. So what we know from this? You have two equations, right? When you have electric field at any point, electric field is given by what? KQ by R square. So that is nothing but K into, that is 9 into 10 to the power 9. What is the value of Q? The capital Q, they have not given, right? So we will use as it is. Okay, capital Q divided by, what is the value? Here, R square is nothing but how much it is given, that also we don't know. So let us take it as R square only. Clear or no? Read out. Keep this as equation 1.
No.
We know that Vp is nothing but KQ by R. What is the value here? K into Q. Also this Q we know that, R we don't know. So let us take this as equation number 2. But we know the value of Vp. Vp is given as what? Here also substitute these values. What is the value given here? It is 24 Newton per Coulomb. Here it is given as 12 Newton. Here, let me keep this equation without any substitution. So this is equation 1 and this is equation 2. What we can do in the equation 1, 24 will be equal to KQ by R into 1 by R. Can I substitute, ma? And what is from equation 2? What is KQ by R? KQ by R is 12. So 12 by R can I take? So this one will become 2. So what will happen? R will be equal to 1 by 2. That is 0.5 meter. Clear or no? Mathematical part, any doubt? I just took the value of EA and substituted in KQ by R square. In KQ by R square, I can split and write KQ by R into 1 by R. But KQ by R value is given 12 Joule per Coulomb. So I substituted that. So I got this answer R directly. R is nothing but what? AB, right? Yeah? Everyone?
Yes, ma'am.
Good. So the next one is what potential? Yes.
Now, for the previous example, we also have to find the magnitude for Q.
Okay, distance and the magnitude. Very good, very good. I forgot that. So what will be? Let me just. Yeah. Now we know the R value. Substitute it in any one of the values. So what is Vp? Vp equal to KQ by R. That is equal to 12. So KQ by R is 12. So what is R? R equal to 0.5. That is 1 by 2. Substitute that value. It will become 6. So Q will be equal to 6 by K. What is the value of K? It is 9 into 10 to the power 9. So on substituting 2 by 3, it will be 2 by 3 into 10 power minus 9 when it goes coulomb. That is nothing but 0.66 7 into 10 to the power minus 9 coulomb, or simply what you can write 0.67 nano coulomb. Yeah? Good.